the demonstration and show how the anomaly detection can operate within the Trino environment. So to talk through what we looked at earlier, we have the machine learning model has been built and trained on normal user activity. And we're going to start up with this script, the inferencing that leverages that pre-built model. So we'll start this up. You'll see it reads the PK files and it is now loaded the model. So over in this SSH tab, we'll start up background traffic. So it's a bunch of random users accessing tables in Trino. You can see the username and inserting some rows. So this is some random traffic on different tables. So in this state, if we come back to the inferencing model, you'll see no anomaly detected. So this is processing from the Kafka topic, all of the events that are being generated, extracted through the event listener, published into Kafka using the Superna cyber storage framework, which I'll talk about a bit more. Once that audit data is published, our inferencing engine and threat detection engine will consume Kafka records and perform the inferencing lookup against the model and is looking for anomalous behavior. So right now, we still have that background traffic running. We don't have any anomalies. So I will start up an anomalous behavior on a specific user account, and that will merge in the audit data and publish into Kafka, and we'll see how the detection engine functions. So we will start the anomaly script. It says a single user, and it's modifying various data in various tables. So this user is in the background traffic, but doesn't normally do this. So if we come over to the inferencing engine, we can now see we have detections. So we're continuously looking at the event log data that's coming out of the event listener, and we're comparing it to the model. And what we can see here is that this table is the subject of the anomalous behavior. This is the user, and this is a bit of data about what they're doing. And this would be used and combined into a much larger set of models that combines this and provides a confidence score. That confidence score is designed to tell you how much that behavior deviates from normal. So if we go ahead and stop background traffic, now this is stopped. We'll start this up again. And you can see now there are no longer any detections. This is the exact same process or concept that works at the underlying data stores. So when we have file systems and we have object stores where data is being stored, this new approach to securing a data lake allows us to correlate a user that's authenticated into Trino, the tables that they're operating against. We can then extract the definitions of those tables, map this anomalous behavior to the storage device itself. We'll go through a similar process of extracting audit data, publishing into Kafka, doing an inferencing function. But by correlating the behavior here, we can then correlate the behavior at the file level and create a trust from the SQL layer all the way down to the files or objects or both. And we can discern that the file system or object behaviors IO that we're seeing is attached to either good SQL behavior or bad SQL behavior. In addition to that, we can also independently protect any IO towards the data stores that does not originate from Trino. So administrators or anyone trying to side mount Parquet files or directly manipulate the data that's being created or modified or searched would also be in the sphere of scope of the threat detection engine. So this expands essentially the file system object security layer up into the SQL layer and lets us do correlation and end-to-end mapping of a query to the files that comprise the tables in Trino.